We are so happy to welcome Ilia Opiakin. Ilia is a senior engineering manager at Wayfair. He has 15 years experience in planning, optimizing, and managing global large-scale IT infrastructure, and has extensive knowledge of SQL Server. His specialty is building high availability architecture, performance tuning, TSQR development, and security configuration. Today, Ilia will talk to us about building high availability architectures in SQL. Dear Ilia, the screen is yours.
Thank you very much. By the way, do you see my screen?
Yes, we do.
Yes. Okay, let's start.
Perfect.
So, thank you very much, Safa, for introduction. And today we will talk about building high availability architecture in SQL. And when I was preparing this presentation, I thought about the auditorium, about you. And I was trying to answer the question, what would you like to get from this session? From one side, I don't like to have this super technical because it's boring and it's really limited in case of scenarios. From other side, I would like to be super general because again, it does not make sense. And for me, it was not real task, and I hope I will be successful here. So let's see. High availability architecture. A few words about myself. So as Safa mentioned, I'm senior manager in Wayfair. I'm responsible for data infrastructure. And my primary goals is to keep the data infrastructure up and running, available, and consistent. I'm DBA since 2005, primary Microsoft area and Microsoft SQL Server. And here is my link and my photo. What's our agenda? I'd like to spend 30 minutes to walk through my slides and talk about the takeaways that I'd like you get from the sessions about CAP theorem and ACID, about availability versus budget, describe some disaster scenarios, and propose some solutions, most common, like load cluster, availability groups, and cloud. Also, I created an additional slide with all links and references that we use for this presentation. And we will spend about 15 minutes for questions and answers. Takeaway. I'd like to start any conversation with the question why. Why we have the session? Why you have this curiosity about this topic? What the problem are you trying to solve? And here is some takeaways that I hope you will get after this session. The main one, that different data platforms, different data engines like MySQL, Oracle, Postgres, Cassandra, MongoDB, they have different options, different pros and cons. You need to recognize the potential threats, impacts, evaluate this impact, and set the clear problem statement. So this is really important. And again, answering the question, why are you solving this problem? What are you trying to achieve? It's good base to start your journey in high availability. The next one is a balance between potential benefits and real budget. As engineers, we don't think too much about the money, and it's important because all solutions that you're trying to implement on your environment, everything that you bring on the table, it costs money. And here is the real challenge for everyone to understand that the benefits that you provide by the solution is cover your budget. And also we will talk about some common high availability scenarios. So that's the takeaways. I hope you will be comfortable to answer this question after this session. So let's continue. Let's talk about CAP theorem. It's a fundamental theorem from computer science. And in few words, it says, having distributed system, you can achieve only one parameter of the system, data consistency or data availability. Unfortunately, you cannot achieve both of them if your system is distributed and if these partitions are separated. Let's talk about consistency. What does it mean? Consistency means that you have exactly the same data on all nodes, on all data servers that you have. It's like your bank account. You have Deutsche Bank account, you put some money here, and you can be sure that on any ATM worldwide, you will check your balance and you will have the same amount of money that you have on the main office. It's a data consistency. There is no chance that you have a different amount. Availability is different. It means that every time you go to the office and the office is open for you. But it means that this office might have no synchronization with the main one, or they have a specific time frame for this synchronization. So there is a chance when you come to the second office, they have no fresh data about you, or this data is in delivery state. So again, it's a high availability. The both offices are available for you, but data is inconsistent. So these two main part that you need to keep in mind, and it's a trade-off for you. What is the goal? What's the problem that you're trying to solve? You need to ask this question to you to pick the right solution. If you focus on that consistency, it's a transaction database like Oracle, SQL Server, Postgres, MySQL. If you talk about availability, it's Cassandra, NoSQL solution, which provide, again, more flexibility with eventual consistency. So that's about Cerium. More older one is ACID, is a set of prescription that we use to describe quality and properties of transactional database. ACID is all about transaction, and it's acronym. What stands for this acronym? A, atomicity. It means all or nothing. If transaction begins, it should be completed 100% or roll it back. There is no half-half situation, everything or nothing. Again, if you talk about your bank account, let's imagine a situation. You transfer your money to somebody else and transaction begin, bank remove some money from your account and put this money on your friend account. Transaction committed, 100%, we are good. Just imagine if something is broken in the middle, your money is removed, but they are not delivered. And this situation is not consistent because you just lost the money. That's why if something is happened in the middle, we have to roll back everything that we've done to the beginning of the point. So the money that was removed from your account should be returned to you. It's really important. Consistency, as I mentioned in the previous slide, it's a guarantee that your data is consistent state. Every transaction which is committed should be consistent. So after each transaction, database is in healthy condition and it provides a real good data. It's really important. There is no transaction, no internal logic for database which might have put this database in inconsistent state. So after every transaction, it should be in good state. That's really important. Isolation, the third one. It means that all transactions are isolated, each of order. If you start transactions 2, 3, 5, 10,000 in parallel, there is no way that they will intersect and affect each other. They are isolated, and that's also important. The next one is durability. committed data is never lost. Of course, it's a theoretical point. We have hardware which might broken, we have electricity which might end up, and there's a main situation that can prevent to keep this durability on the good level. But in theory, if transaction is committed, it should be written on the disk, and this data should be available for you. And of course, it's your responsibility to think how to duplicate this data, how to keep backup somewhere in safe place to return it back. And there's another really important point. It's a theoretical fundamental concept, and practical realization might be different from one to other data engineering. For example, Oracle engineers, they might have a different vision how to implement isolation than Microsoft, and MySQL the same. So when you work on one platform like MySQL and you migrate your data to, let's say, MongoDB, you need to know how this new tool works with isolation, how this tool interpret consistency, because something that works fine in Oracle might not work the same way in Microsoft. So migration from platform to platform is important, especially if you operate with real and serious data. So that's about this. Let's move forward. And here's some common requirements that people define for their data systems, SLA, and the cost. I often hear the following requirement. I like to have my data available 24/7 without no outages at all. It should be available for every employee worldwide, and I have to have this copy in each country to minimize delay. Okay, it's possible, but it's cost a lot of money. And let's talk about SLA a little bit. On the table on the right, you can see the concept of SLA names nines. And nines means percentage. How much time per year, per month, per day data is available. 90% of time, 99% of time, 99.9. So 3 nines. And it means, for example, 3 nines, this service guarantee for you that your system might be unavailable maximum 8 hours per year, less than 2 minutes per day. 4 nines guarantees that this service will be unavailable maximum less than an hour per year, 8 seconds per day. And it's important to know, cost is not linear, it's exponential. You need to pay more and more for higher level. And it's important to ask the question, why I need this level of support? What problem I'm trying to solve? What's the impact for my system if my system is, what's the impact for my business, for my project, for my colleagues, for my company, if my data is unavailable? And there's a good small example we can walk through together to answer this question. For example, let's imagine we have fresh stand-up. It's not profitable yet. We just produce some samples. We have one laboratory assistant and one microscope. You use this for analyze this data samples and put results in database. Here's the cost. It's the only cost that you have for simplicity. You spend some money for salary of this assistant and for microscope fees, $21 per hour. Let's imagine your database totally unavailable for 1 month. Your loss is about $4,000. Yes, because you still have to pay by contract to this guy and this microscope. Loss per day is about $200. Okay, not big, but that's something that you have to pay. If you choose your SLA contract, like 2 nines, it means that they guarantee that per month this system will be available maximum not more than 7 hours. It means for you maximum amount of money that you can lose is 153. Okay, much better than totally unavailable system. But what you need to do before? 0 is a worst case scenario, and of course it's not real. You need to grab some statistic. That's why you need to collect some data for 2, 3, 4, 6 months about how stable is your current system. You did it well. You collect this information and you find out that you had 8 outages for last 3 months. 32 hours in summary. What does it mean? 32 hours of outage cost for you about $7,000, $224 per month. Okay, not much, but again, it's loss and you need to mitigate this loss. You go to provider and say, I'd like to make a contract. You guarantee uptime of my system 2 nines and how much it costs for me. And here you can make some calculation. Your average loss with guarantee SLA 2 nines, 153, and difference is 71. So $70 is the maximum amount of money that does make sense to spend for this contract. If you spend more, it's exactly the same like you have no contract, because in summary, you will spend more than normal work. So that's something that's important to know. And it's really simple example. Now think about, you have more people, like 100. You have office you need to pay for. You have a lot of contracts. You have your customer, and you have big flow of money. So you need to get this into consideration to think about how much do you need to spend to keep your system available. How much costs this outage? And it's really important question to you to start thinking about high availability system. Okay, let's move forward. Here's some disaster scenarios, from the biggest one on the down to the lowest one. For end user, it looks the same. Database is unavailable, but there's a many reason behind. It might be unavailable because database is corrupted. Okay, easy case. Maybe it's something wrong with SQL engine. Okay, not so scary. Maybe it's operation system down. Okay, not a big deal. Server hardware, it's more serious, but doable. Storage, okay, it's more serious. Network, problem is big. And facility, like electricity, air conditioning, cooling, fire, maybe, is the biggest one. And you need to think about how to mitigate impact on every stage. So for database, it's corrupted, okay, let's have a copy somewhere. SQL engine, we need to have up and running instance again somewhere else. The same for operation system. Server hardware, let's have 2 servers or 3 servers or 4 servers to move the database between them in case of a disaster. Storage, okay, we need to duplicate the storage and maybe keep this in different data center, or maybe rent storage in Google and a cloud provider. That's option. Network, a really serious one, because it's not something that you can rent out. Of course, you can have your own network engineer, your own network equipment. You can have a contract with a company who arrange and maintain your network, but again, it's a single point of failure for you. If you're a big company, perhaps you need to have 2 or more contracts with different organizational and dedicated network segments to be sure that you always have access to internet, You can switch your users from one segment to the second. It's a huge project and it costs a lot of money. And facility, yes, is super expensive. Let's imagine you have a big office and electricity is down. What you can do? You cannot buy UPS for each device. Gathering generator, okay, might be a solution, but how many of them do you need? So all this question you need to ask you before you play in this high availability solution. And in general, solution is, there's a 3 options for solution. Backup. You always need to back up your data, back up your engines, etc. Redundancy or duplication. It's straightforward. If one box is down, you always have the second that you can move there, of course. The second is not 100% available in theory. You can buy the third one, the fourth one, the fifth one. And in this case, you decrease the chance that the whole system is down. And of course, it costs money. And the third solution is workaround. And here is really important that it's all depend on you as engineers, as the stakeholders, because it's something that you need to invent, especially for your case. It's a creative task. You need to think, okay, even if the system is not available, what can I do to minimize my cost, my loss? Perhaps I can use this or something else. If you talk about our stand-up with a laboratory assistant and microscope, workaround here is super easy. This guy needs to continue his work, put the result on the paper, and then when the database is available, just upload this data there. Not perfect, but again, we have some progress and our loss is minimized. So workaround might be a good solution for you. It might be cheap, it might be creative, and it might save you from a bigger problem. Let's move forward. Here's the simple example of failover cluster instance. It's a pure redundancy system. It's a duplication. Here is the example. You have 2 different data centers. You have 4 servers to move database between them. And you have 2 dedicated shared storage with synchronization. So if node 1 is down, you can move database to node 2 and it will be available for everyone. If shared storage on the site number 1 is down, you can move your database on site number 2 and again it will be available. It's good, it's straightforward, it's really bulletproof solution, but you need to spend a lot of money because you have to buy this equipment. What's the benefits of this? It's protection on the instance level. So whole instance is protected. All databases within this instance are protected. You don't have to think about this. It's really easy. Failover is configurable. You can configure to be automatic. So in case of failure, it's just short blip and data is available for you again. It supports a lot of storage. You can use iSCSI, fiber, optic, SMB, share files, anything. It works very well. And good news, there's no impact for application side. It's really transparent for application. You need to configure it once and that's it. It works. So that's about the cluster. Next solution is a Microsoft solution named Always On Availability Groups. The idea is they use log file where database engine stores and keeps all transactions. And a special service read this transaction from log file and apply this transaction in background mode to the second copy. This is really good because we don't have a storage system as a single point of failure because we have dedicated storage per each server. We can use second copy as read-only available copy. In case of cluster, it's just standby, it's offline, it's ready to work in case of failure, but it's offline. Here, it's up and running, it's available for read, and you have a luxury to route your traffic. Read-write traffic to the main node and read-only traffic to the second node. Good news, if you have a lot of reads, you can introduce second, third, fourth, up to 12 read-only nodes for this purpose. And of course, you also can make this solution geographically distributed between, let's say, Berlin and New York and Sydney. There's no problem. Configuration for this lock applied is asynchronous. It can be synchronous, but it's recommended to be in scope of one data center. If you work with geographically remote data centers, it's better to have asynchronous. So, what's the benefits of here? No shared storage solution. You can configure availability level per each database. If you have, let's say, instance with two databases, one is archive and really old one and huge, and the second one is fast transactional one, you don't have to configure this availability mode for both of them. You just pick this database that is really important for you. You can configure second replica for read-only to route the traffic there. And again, you can configure automatic failure as you want. So that's a good one. Third solution is clouds. And here we have plenty of options. The biggest three players is Amazon, Microsoft Azure, and Google platform. And they provide a lot of scenarios for database. If you like Microsoft SQL, go to Azure. If you like MongoDB, Cloud, or Amazon, Postgres, Oracle, MySQL, almost all the popular platforms are available there. And they usually provide 2 or 3 types of scenarios. You can get database as a service. So they just create a database for you, give you a connection link, and that's it. Done. They can give you instance. So you can create as many database that you want within this instance, configure what you want, play with isolation level and tweak configuration as you want. That's really flexible. And the third bulletproof solution for everyone. They can provide you an empty virtual machine with Linux or Windows on the board, and you can install there everything. So it's like a virtual machine, but not inside of your office, but somewhere in the cloud. Really easy to start with. Only one point that you have to keep in mind, it's cloud solution. So your network should be really well configured, because if network is down, everything is down. The second point is data security and data protection. It's cloud. Your data might be everywhere. And again, there is no 100% guarantee that data is super protected. So you need to be ready for DataWeek. And another point is especially for PCI, GDPR compliance and source compliance, you need to be sure that this data, which you keep in the cloud, not recognize it as, for example, GDPR compliant data. Because in this case, you need to work with provider to be sure your data is not moving out of European Union. It's tough conversation. It's not easy to work it out, and perhaps you need to work with your legal department to make it done. So cloud is good if you have no sensitive private data, GDPR data, data that you like to keep in secret, like your know-how in this case. cloud is not the best solution for you. But for all the rest, it's way to go. And this tree platform is more and more popular. So that's all about clouds. Actually, I'm finished. Here's the links that I use to prepare my presentation and question and answers. I'm here to answer all your questions if you like. Please go ahead.
Thank you so much. That's very interesting. Where, as a biomedical researcher and medical doctor, of course, it's a pretty high standard that you put together here, and I really appreciate that. I agree with you that the cloud solutions seem very appealing also for us medical doctors because they're so readily available. But on the other hand, we are probably the people dealing with the most sensitive data ever. And that makes it complicated, even when building own solutions. However, what is more easily shared is the research data that we do, and to have databases that include de-identified research data is very much realistic. What I find more and more interesting is to try and link like front-end database searches in the cloud that allow to find data. Is there any solution, and that might be a dumb question because I'm not an IT guy, but is there any way to use cloud solutions to host like metadata search engines that search a local database?
First of all, there's no dumb questions at all. It's IT. There's a lot of new information, and even for myself, I spent my last 25 years in IT. Every day I found something new. So I can imagine I ask a lot of dumb questions to my colleagues because they are always for them. So good question. Yes, it's possible. But the point is, just imagine this search engine is located in the cloud and your data is somewhere on premise. And it means that this search engine should have access to this on-premise data and be ready to read everything per each search request. And this amount of data which is transferred between cloud and data center might be huge. Does that make sense?
Yeah, but we're just, we do not necessarily want to transfer the data, but we want to tell that the data is there.
Yes. So again, it really depends on the type of information that you're trying to search. Let's imagine you have your own data center with data. You have search engine in cloud, and you have somebody who uses the search engine. And this guy came to engine and said, okay, give me all information about the products which begins on the wildcard. So almost everything. And this engine goes to your data center and will try to get all this data and give it to him. So it means that there's two transfers from data centers to the engines and to the users. So you need to be ready to have some limitation about how many data you're going to provide to users. Is it just a high-level metadata, or it's a deep one with some PDF files, maybe binary files, etc. Does that make sense?
Yes. Yeah. Thanks.
Yeah, totally.
Any other questions?
You're on mute. You're still on mute.
Yeah, I want you to ask, what do you think about open source clouds out there? Do you think it's reliable? What do you think of it in general?
Open source cloud, that's interesting. So, okay, cloud is a business, and company who runs the cloud supposed to have some profit of this business. Of course, they can use open source code to build this, but there's many limitations. Some open source code cannot be used for having profits at all because of the license. And having open source, again, it's really, really hard thing to run in big companies. So in general, it's an interesting idea, but I think there will be a lot of on-premise code which is hidden, and maybe it's a big secret.
Yeah. Hi. I have another question.
Yes, please.
It's about basically the limits of like large data sets in databases. So you know, we once considered putting like large data sets of time series data directly into a database, but you very soon run into limitations in terms of what databases can handle. And I wonder if you could say something about what are the limitations and what are the bottlenecks and what are the things to consider for what sort of data can be put into a database, and to what extent you basically are just limited to storing metadata, which is obviously much simpler than the actual data itself.
Again, it depends on the problem that you're trying to solve. So you need to ask your question, why I need this data, and how this data is important for me. So if it's time series data, it means that you put 100,000, maybe millions rows of data per minute or per second. And of course, you have to limit this database size, otherwise it will be overflowed. And the question is, how much data you need to have available from this particular database, and how much data you can archive. So let's say your business needs to make this data available in 2 days for really fast response, and you can still have this configuration. And then you can say, okay, I'm going to archive all the data that older than 2 days to NoSQL database. Maybe it's Hadoop or Hive. It's up to you, and it will be available there. What's the trade-off? It's still available, but with bigger delay. So for time series data, it's important to have access to the fresh data, like 2, 3, 4, maximum 24 hours ago. For all the rest, again, it's trade-off. Also, you can, what I recommend is to gather some statistic. What's the most popular query for this data? Which data is extracted from what period of time? And you can have some diagram, like 80% of data is for last 3 days, 10% of the data for last week, 1% of data, 1% of queries is for data more than 1 week. And answer is obvious. You have to archive all data which is older than 2 days. So that's recommendation.
Yes. I think, Ilia, from our perspective, we are not so much dealing with the a business website. It's more dealing, like making data available for a large group of researchers, and this data has to be complete. It's not a question of like how much is it used. It's really present. And I think that John's question was very good, because we are dealing with limits. So our data sets are up to terabytes.
Yeah, yes, that's, sorry, Wolf. So that's my suggestion. When I say archive, it not means that you pack this data in zip file, write on the cassette and put away in the bag. It means that you use a different data engine to keep this data available. So you need to, let's say, you have a 2 database engine. First one is the time series, And the second is archiving database. It might be, again, 2 terabytes is not a big deal. Microsoft SQL Server works with this. And you need just to change your application a little bit. And depends on the query. If data is fresh, like 2 days, it extracts this data from time series database. If your query trying to get data older than 2 days, this application go to SQL Server and extract this data from there. And for user is transparent. Maybe it's a bit longer for all data, but again, it's here, it's available. Does that make sense?
Yeah, I think, I mean, for most experiments, it's not usually it doesn't matter so much whether it was done one day ago or a week ago. I mean, there are different criteria, but I understand the basic idea of making distinctions between.
Yeah. So again, you're absolutely right. There's a timestamp. Maybe it's not a good criteria. Maybe you need to gather statistics based on different data types. For example, if you have, I don't know, let's say timestamp, laboratory number, name of the laboratory assistants, type of project, and perhaps you see that this project type is the most popular. So, okay, it does make sense to keep this project on the top and all the rest move to the second database. So idea is to divide this data somehow.
Okay, thanks.
Okay.
Great. Thank you so much, Ilia. As we talked before, me and you, we in research usually these infrastructures and servers got provided for us from the our institutions, but it's really it's important, and it's really good that we as end users have insights what's going on in the background. What shall I check with my institute? What stands as going on behind there? Thank you. It was a very valuable and very new information for us. Thank you so much, Ilia. And do we have any other questions for Ilia from the participants? And I will check our pad.
No, I think that's
great.
Okay.
That's
Thank you
so
very
much.
much.
Thank you.
It was my pleasure. Thank you, Safa, for the invitation. Thank you, Wolf, and
thank you so much.
yeah, wish you
It was
best
our
of luck.
pleasure to have you. Thank you.
Thank you.
Bye-bye.